All right, this is Algebra 1, Chapter 8.6. Today we are going to continue factoring, but now today we're going to get into trinomials. And our trinomials, guys, remember trinomials are three terms. We're going to solve, basically factor by solving, trinomials in the form of x squared plus bx plus c. These are the easier of the trinomials that are going to need to be factored. So, hopefully you remember some things about binomials. That when we multiplied two binomials together, we used a FOIL method, and that allowed us to, like the example here, FOIL to get a first squared each of the I and the O, so you get 4x plus 3x plus 3 times 4. First, outside, inside, last. And of course, those middle terms always seem to add up, right? Well, generally, most 99% of the time. And so we can actually make this 4 plus 3 times x. 3 times 4, which is 12. 3 plus 4, 7. So we are able to multiply these together. Well, today what we're going to do is we are going to go from this trinomial to this factored form. The very basic outline of that process, here I took out the numbers and put variables in, is if I had x plus m times the quantity x plus p. It's the same thing as we had above, where the 4 and the 3, as you can see here, are the m and the p. I end up with this step right here, and that's it right here. We see that when I go to multiply those two things together, I'm adding the two terms, okay, and I'm multiplying the terms at the end. And so we're going to use that. So notice that the coefficient in the middle term is the sum of m and p, and the last term is the product of m and p. So that's the pattern we are going to use, that if you factored or get some trinomial, we'll be able to go from this, or should I say this, to this, which leads us to the factored form. And that's what we're saying here. So we're going to factor here, factor trinomials of ax plus bx plus c into two integers, m and p, with the sum of b and a product of c. Basically, it says that you're going to add two numbers to get to b and multiply them to get c. And so if you get something like this, trinomial, we are going to be able to break it to x plus m times x plus p. So, there are some different times when the signs will change. So, when c is positive, its factors have to have the same sign. Because the only way to get a positive answer, or the two ways to get to a positive multiplication, is if they're both positive or if they're both negative. So that's interesting. Now, if b is positive, the factors are positive, and if b is negative, the factors are negative. Let's see what that means here is that, again, all based off of c. If c is positive, that means I have to have two positive or two negative. But if the middle number is positive, then both factors are positive. If c is negative, or c is positive and the middle is b is negative, then the two factors themselves will be negative. So that kind of dictates how your signs will play out. Now I'm going to move kind of fast through these because you guys can pause the video and replace it as much as you can. But here we go. Let's go on to a couple different cases. The first case, guys, is if b and c are both positive. And I see that I messed up on this first one, so we're going to fix that real quick here. That would be d squared. So d squared plus 11d plus 24. I want to factor this. Now, the next time we meet, we probably will go into when that number in front, that leading coefficient on the squared term is not 1, but it's a 1. Which you're going to hopefully find to be really nice. So, this is what I would like you guys to do. Right away, you have a trinomial, you're like, hey, I'm going to be able to factor this into two binomials. And the cool thing is that you're kind of working that pattern out. You're like, wait a minute, the only way to get d squared is if it's a d and a d. And so d times d gives you d squared. Now we move on to c. C is 24. That's our last term, a constant. And now what I want you to do is I want you to go off to the side and start listing your factor pairs. So 1 times 24 is 24. 2 times 12 is 24. 3 times 8 is 24. 4 times 6 is 24. That is your list. That's your possibility list that you will have to check. Now, you could put 1 and 24 in here. And since both of these signs right here, it's plus 11d plus 24, b and c are positive, that means both of these have to be positive. Because the only way to multiply to a positive answer and have positive in the middle, because when they add up, is if they're both positive. So if I took a guess here and said, hey, is this my answer? I can just check my work. You can check every single one of these factorizations to make sure you did it right by using FOIL. D times d, obviously, is going to be d squared. We engineered it that way. We set it up that way. That's awesome. But now you go all the way over here. D times 24 is 24d. 1 times d is d, and 1 times 24 is 24. D squared's fine. 24 is fine because we found the multiples of 24. We know it was d times d. But does this add up to 11d, which is our original problem? And the answer is no. So this is one way. You can keep testing your list over and over and over and over and going down the list. It takes a long time. So I suggest that you back up and we go back to here and we look at our list and we just say which one of these numbers in our list will add up to 11. 1 and 24, not getting you 11. No adding, subtracting, no way. 2 and 12, nope, you're jumping right past it. But 3 and 8, yes. 4 and 6, not enough. So that means I am going to use the 3 and the 8. So again, I set up my parentheses. I put D, D. I'm going to put a 3. I'm going to put an 8. And because both of the signs inside are positive, both of these will be positive. And check your work. D times D is D squared. D times 8 is 8D. 3 times D is 3D. 3 times 8 is 24. And what is 8 plus 3? 11. So therefore, we checked it. It works. This is your answer. D plus 3 times the quantity D plus 8 is the same thing as D squared plus 11D plus 24. You just factored it. So let's move on to the next one. Again, I think you could see that we have positive terms. They're all positive. Trick is, they did not put it in standard form. So you're going to have to put this in standard form. Remember what standard form is? Highest to lowest power. T squared plus 10t, I'll make a better t plus 9. So again, I got positive terms. T's are probably not the best thing to put for polynomials because they do look like plus signs at times. But here we go. I'm going to go to, because t squared has a value of 1 in front, that's the ones we like, I'm going to go look at my constant. And my constant says that I have a 9. So 1 and 9, 3 and 3. You like ones like this. They're relatively small values that can go to it. You don't have very many choices. But of those two choices, which one will give you a 10? Right, it's the first one. So guess what? Real simple. It's t, it's 9, it's 1. Both signs are positive, therefore both of these are positive. That is your answer. If you don't believe me, check it using foiling. The next set of problems now is that B is negative, but yet C is positive. So when this happens, remember from that very first slide that since c is positive, you're multiplying to get positive, but the middle is negative, both of them will be negative inside. So again, it's not in standard form, so m squared minus 22m plus 21. M is positive 1, B is negative 22, and C is positive. So positive value of C, negative value of B, which means I need to find values that are both negative, because when they both are negative and multiply, they become positive, but add up to a negative. So values of 21, 1 and 21, and 3 and 7 are our only options. So, which one of those, 1 and 21 and 3 and 7, will give me a 22? Seems like a no-brainer. 1 and 21. So I go and make my parentheses, m, 21 and 1. Now remember, I could have put 1 first and 21 second. It doesn't matter because you're multiplying. And here's the thing. It's going to multiply to get to a positive 21. But when I go to add them, they have to add up to a negative, which means this has to be a negative 21 and negative m. Why? Because m times negative 1 is negative m, and negative 21 times m is negative 21m, and when I combine like terms, it's negative 22m. So therefore, there's your answer. These, again, are nice. They're going to be easy. We like ones where a is equal to 1. Moving on to the next group. The next group already has it in standard form for us. So 1 and 28, 2 and 14, 4 and 7. Which one of these will give me 11? I think everybody should see 4 and 7. Make my brackets. W, 4 and 7 has to multiply to a positive but add up to negative. The only way 4 and 7 become a negative 11 when added is if they're both negative, but two negatives multiply to give me positive 28. You've now just factored. And again, I highly, highly, highly suggest you check every single one of these by foiling. Moving on to the next group. The next group is what happens if C is negative? Because now we're going to have some issues where you're going to have options. Because when you multiply to get to a negative, one of them is positive and one of them is negative. And so, here we go. It's already in standard form. You therefore can go for and say A is 1, so we'll just ignore that fact. Start looking at factor pairs. 1 and 48. Notice I don't even care it's negative. I just want to know what are the factor pairs. 2 and 24. 3 and 16. 4 and 12. I don't know if any of these are actually working yet. Oh, maybe one of them will work. Next, 5, no, 6. 6 and 8. And I think we are done with the list. So what's the difference about this one versus the last one is that they're not both adding to get to our number or subtracting. One's going to be positive and one's negative. So now your job is to find two numbers that somehow, when put together by adding or subtracting, can give you 13. And I think everybody should see that 3 and 16 can give us 13. How? When I have a plus 16 and I minus a 3. That will end up giving me my 13. Because y times negative 3 is negative 3y. 16 times y is 16y. And when you add those two together, you end up with what you need. So, moving on to the next one. Factors of 24, 1 and 24, 2 and 12, 3 and 8, and 4 and 6. And so, which one of these has the option of giving you a 2 or a negative 2? And I think that we would all agree that 4 and 6 would work. So, we go to set up our factoring, R, 4 and 6, but I gotta get to a negative 2, which means the 4 has to be a positive and the 6 has to be a negative. Okay, so moving on to the next ones. The next ones, I'm going to let you guys work on here. But working on what we did yesterday is that we can solve these by setting them equal to 0 and using the zero product property. And remember what the zero product property was again. The zero product property says that if you have two numbers multiplied to 0, that A equals 0 or B equals 0. So we're going to use the same techniques you did today, but then you're going to set them equal to 0 and solve them individually. So kind of like what you did at the end yesterday with the factor by grouping. So give you guys a couple seconds. Hint, bring everything to one side and factor. Okay, so hopefully you had paused the video. If not, pause the video, give you guys some time to work on these. That's the best way to do this. And here we go. I think everybody should realize that we have to subtract 70 from both sides because I want this side to equal 0. And so I will get z squared minus 3z minus 70. Now granted, not granted, but you can see that I put everything in standard form. And by putting it in standard form, it allows me to see it's a trinomial that I can try to factor. Now, 70 is a pretty big number. And 3 is kind of a small number. So, I'm guessing 1 and 70 won't cut it. 2 and 35 won't cut it. 3? I don't think so. 4? I'm not seeing it. 5 will, for sure. 5 and I think 14. That's getting close. 6, I don't think so. 7? 7 and 10. 8, no. 9, no. 10. Oh, 10's back to this. So there's my list. It's actually not that big of a list, but it took us a while to get there because you have to kind of know your times factors to get these. So let's go in here and we'll put these together. Z. I think to get 3, I have to use a 7 and 10. So 7, 10. Notice that 70 is negative, so therefore 1 will be positive and 1 will be negative. And since I want to get to a negative 3, the 10 will be negative, the 7 will be positive. So we just factored it. Now you can test yourself and say, hey, is this the right factorization? Z, so let's do this. Z times negative 10 is negative 10z plus 7z is a negative 3z. So yes, we're right. But remember, we did this so we could solve it. And to solve it, I now have two groups of numbers that are multiplied together to equal 0. Which means I can separate to both of these equaling, to equal 0. And so by doing this, if I subtract 7, I get z equals negative 7. And if I add 10 to both sides, z equals 10. And you have two answers. And that's awesome. Another thing you can do with this is take those negative 7 and 10 and plug it into the original formula here, and both sides, the left and the right, will equal each other. So take the time, try that second one again if you did not get the first part. So let's work on this last one. It's already in standard form. So we have two groups. When we factor that, that'll end up equaling 0. And x, we got to find the factors of 18. So 1 and 18. We want to get to 3. 2 and 9, not going to happen. 3 and 6. I think that would be about all we can get. And I think 3 and 6 are the winners. So 3 and 6 has to be a positive 3, so the bigger number is positive. The smaller one's negative. Hey, these aren't too bad. X minus 3 equals 0. Or x plus 6 equals 0. Add 3, x equals 3. Minus 6, x equals negative 6. And there are your two answers. Again, make sure you check all of them. And so everything should work out great. Your homework for this is going to be then the worksheet that is going to be provided for 8.6. Have a great day.